Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, where you're waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can actually mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but y'all, rotely repeating steps actually keeps students from being the mathematicians they can be.
So, Pam, I was looking at the podcast episode stuff on my podcast listening, and I found a review that I wanted to share with you. It's my favorite.
Cool. Cool.
So, Prudent Mama said, I was listening to episodes 24 to 27, where Pam discusses the different kinds of math students that are commonly found in math class and beyond. I felt exactly like the person who just wanted to understand math. I knew it had to be figure-outable since others were doing it, but I could never see the connections and would ask why constantly. Until, she says, ultimately, until I married my husband, who's an ex, I just assumed I didn't have the math gene. Since watching my husband play with numbers and homeschooling my kiddos, I have discovered the wonder of connections in math and can truthfully say it's enjoyable. It's super cool. And just for giggles, Pam, I'm creative with math too through sewing. Honestly, I've shared the podcast with many and highly recommend that you listen to it. I love that. Thank you so much. If you aren't sure what Prudent Mama means when she talks about her husband being an ex, I would encourage you to check out episodes 24 to 27 where we talk about it. And so thanks for the review. We love it. It's super fun for us to hear, and it helps others find the podcast.
Yeah, so thanks. If you don't mind right now, everybody, whoever's listening, pop on over to wherever you listen and just give us a quick review, give us a quick rating. Really helps spread the podcast around so we can transform the world, y'all, and help everybody open the door. Just think, Prudent Mama, everybody could know that they have the math gene, the more that we can spread that. Let me just maybe note, Prudent Mama, that you were a Y. I'm just going to suggest because now you're an R. An R for real math. And I know you said that your husband was an X. Maybe he's actually an R, right? For real math. When I did those X, Y, and Z sort of perspectives, it was an attempt to describe what you might have thought about math in school and how that could affect the way that you teach now. So we don't want anybody to be an X, Y, or Z now. We want everybody to sort of join the team R, the team real math. So, yeah, everybody join Team R, Team Real Math. It's totally fun.
Yeah. And if you're curious about what Team R or what would it have been to be an X, Y, or Z, you can take Pam's quiz to find out what that perspective is that you had as a student. And you can find it at bit.ly/XYZ quiz. Check it out.
Cool. All right. So today, Kim, we're going to have a little fun with Clothesline Math. Yeah. Bam. So Chris Shore, thanks for making it popular. I know you didn't invent it. You give some credit to some other folks. And I had seen some other people do things, but Chris Shore's done a great job of getting a website with lots of examples of ways to do clothesline math. Clothesline Math. It's literally the line that you hang up to dry your clothes on. But instead of drying your clothes on it, we're going to hang numbers on it. And the ability to be able to move numbers around as you sort of shift and organize. Kim, I remember back in the day when I was very first starting to work with elementary teachers and doing professional learning in my kids' school, and you were there, Garland Lincolnhoger. Hey, Garland, how's it going? Shout out to Garland. Was a fantastic colleague at that point, and she brought in some activities that we did with Clothesline Math way back then. Super fun. So we thought we would do a little Clothesline Math on the podcast. You're like, Pam, how are we going to do it on the podcast? Well, I don't know, but we're going to do our best to see if we can make this work a little bit. I'll tell you, as I'm talking, I'm grabbing my pen
pencil
and my paper. So I really should grab like a clothesline and numbers, but since we're audio, we're just gonna kind of do it in the air here, and I'm gonna probably write some things. But a thing that we could do on kind of this, if you picture kind of a clothesline hanging up, and then we're gonna hang pieces of paper or cards that have a number written on them, and we're gonna kind of say, hey, that's where it goes on a number line. So that's the point here. Is if I were to say, hey, Kim, what's bigger, 4/5 or 3/5? And so therefore you would put them on the number line so they would go in the right order. What are you thinking about to determine what's bigger, 4/5 or 3/5? 3/5 or 4/5? Which one's bigger?
4/5 is bigger.
You didn't have to think about that very long at all.
No. So the way I think about those is 4/1/5 compared to 3/1/5. So it's a pretty easy comparison if you think about 4/5 as 4 of those 1/5. So on a number line, I kind of picture maybe where 1/5 is, but you're finding several iterations of them. So like 3/1/5 would be at 3 of the 1/5 down the number line, and then 4/1/5 would be one more fifth further to the right. So 4/5 is bigger.
Further to the right. Nice. So it's really predicated on this idea that you can think about a non-unit fraction, like 4/5, as a bunch of unit fractions for 1/5. So a unit fraction is when the numerator is 1, when I've got one of the pieces that we're sharing. If 5 of us are sharing, we each get a fifth. What's my share? I get one of those. That's a unit fraction, my share of the fair shared. 1/5. And you're like, hey, if I can think about 4/5 as 4/1/5, then bam, I really liked how you describe that on a number line, that if you can picture where 1/5 is, what does that tell you where the 1/5, if you just sort of stick, in fact, I'll just tell you, on my paper, I drew a number line and I put 1/5 at the very far left, but I don't think that's quite what you meant.
Say that again. Where did I picture a fifth?
Well, so if
I pictured the 0 to 1.
Yeah,
there was
kind of I think you have to have the 0 in there. And so I was just looking at my paper, realizing I didn't have the 0. So what I didn't have was when you said, so therefore I can see 1/5, and then you could iterate 3 of them to be 3/5. I didn't have the 1/5. In other words, I didn't have the length of 1/5 because I had 1/5 at the very far left of the number line. So I didn't have from 0 to 1/5 sitting there in front of me. So as you started to describe it, I backed up my number line. I drew it longer to the left, put the 0 down, and then I was like, here's 1/5. And then as you said, I need 3 of them. Then I'm like, 3 of them would be over here. There's 3/5. And then one more of them. Yeah. So anyway, I just thought I'd describe that because I don't just have the where 1/5 is. I have to have that length of 0 to 1/5. Yeah. Nice.
And I think it's really important is that we're talking about, if we're talking about fifths, we're comparing 3 of those fifths and 4 of those fifths in order to determine which is bigger.
Nice. Yeah. All right, Kim, next question. What is bigger, 1/4 or 1/5? That's your next question.
Okay. So, 1/4 is bigger. And so I think about
isn't 5 bigger than 4?
Yeah, that's tricky. But I think about it in context to help with that. So if I have a candy bar shared among 4 people, then I'm going to get a bigger portion than if I have that same candy bar shared among 5 people. Okay, my part is more. But since we're talking clothesline math, and I'm going to put it somewhere on the number line, I also can think about that same 0 to 1 that we talked about.
Mm-hmm.
And if I'm cutting that span of 0 to 1 into 4 chunks, then a fourth is going to be further to the right than if I cut that 0 to 1 span into 5 parts. I'm going to move further to the right if I cut it into 4 pieces than if I cut it into 5 pieces. I'll hit that first mark faster with fit.
The first mark that is 1/4.
Yeah, it'll
Oh, I see what you're saying. Cool. So if you were to cut that span from 0 to 1 into 5 chunks, you're saying those chunks are smaller. That bit of number line is smaller than if you only cut it into 4 chunks. For the same reason as when you were saying if you're sharing, if you were to share that length, say it was fruit leather, like a fruit roll up. If I had a fruit roll up and you're sharing it with 4 people, you'd get a bigger length of fruit roll up where you would cut the fruit roll up at 1/4 and you'd get that chunk of 1/4 would be bigger than where you would cut it if you were sharing with 5 people at 1/5. That'd be a smaller strip of the fruit roll up. Is that right? Yep. For 1/5. So as I've drawn the number line here on my clothesline math, I've got 0 to 1. I've got 4 marks where I cut it in half for a half and then cut that in half for a 1/4. And that's where I mark the 4th. How are you marking the 5th?
It's a good question.
Like, where does it, if that's the clothesline and I put the 4th there, where's the 5th?
I just eyeballed it, to be honest with you.
Right. But just tell me where.
Oh, the 5th would be to the left of the 4th.
Closer to the 0. Yeah. To the left of the 4th. Yep. Cool. So as I look at the number line, 0 first, then there's the 1/5. And shortly after that is the 1/4.
Yeah.
Yes.
Yep.
Cool. All right. Let's see. What is bigger, 3/4 or 3/5?
3/4.
And maybe I shouldn't have said it quite that way. 3/4 or 3/5, or maybe I should have said it 3/4. How do I say it without any emphasis? 3/4 or 3/5?
Well, either way,
you say
either way you say it. My first inclination was to think 75% and 60%. I know, you know, I love the percent.
I love it. You're such a percent girl.
I know 3/4 is bigger.
So so stay there for a second. So if you stay at 75% and 60%. What was the other one? 60%. Then you could put that on a clothesline math, right? How do you envision the clothesline math there?
I was going to be snarky for just a second. Sorry.
Snarky? We like your snark.
I was going to say 3/4 down the number line. So between 0 and 1, I would put 3/4. If I need to put it on a number line, I'd find the halfway mark, which would be 50%. And then I'd go halfway between the 50% and the 1 for the 100%. And I'd put 75%, which is 3/4, smack dab in the middle of the halfway mark and the 1.
Okay. So I'm just going to slow you down for just a sec. So do you have on your number line 0 to 1?
I do.
So then in clothesline math, as soon as you said 100%, because you did, then I would give you an additional card and we could clothespin that 100% right underneath the 1. And underneath the 0, we could clothespin 0%. So now I have kind of some markers for 0 to 1, and those are also equivalent to 0% to 100%. And when you cut it in half, I think you actually said that's where the 50% went, I think. But we could also then clothespin the 1/2 to that. So right now we've got 50% and 1/2. And then you said you cut that in half. And I think you said, so you'd put 75% there. So therefore it's the 3/4. So again, we would hang 1, and I don't care which one we'd hang first. We could hang the 75% and then clothespin to it. And the reason I'm saying clothespin, because then it just goes right underneath it. So it's in the same position. So now I've got in the same position, 0%, 50%, 1/2, 75%, 3/4, and 1 and 100%. And that's part of the beauty of clothesline math, is that we can have all these different kind of representations. And since you like percent so much, why not use percent? I like it. Absolutely. Do you want to talk about it without percents, or do you want me to?
Well, we already determined that 1/4 is bigger than 1/5. That's the previous problem you gave me. So if I have 3 of those 1/4s or 3 of those 1/5s, then 3/4 is still going to be bigger. I just now have 3 of each of them.
Oh, nice. So you can actually use that unit fraction, kind of like you talked about before. 3/4 is 3 1/4, and 3/5 is 3 1/5. Since the fourths are bigger than the fifths, you got 3 of something bigger, is going to be further along than 3 of something smaller? Yeah, cool. Nice. Nice. I think you have one more way to think about that one, just because I know you. Over girl.
Well, yeah, I mean, 3/4 is 1/4 away from a whole, and 3/5 is 2/5 away from a whole. So if I'm a fourth away from the whole, I went back to percents for a second. So 25% away from the whole, and 2/5 is 40% away from the whole. Yeah. So then the 3/5 is small.
Cool. Hey, so maybe I missed it. Did you actually tell me where to put
Oh, I
3/5?
didn't. No, I didn't.
You just said
Nope.
40%
Well, we
away
had
from the whole,
1/5,
so I could do that.
and we had. So
Well,
I did.
I can.
Mm-hmm. Here's the thing: I didn't put 4/5 and 3/5 as the first one you gave me. I didn't draw it on a number line, but if I had, then I would have already had the 3/5 on there. The first problem you gave me was 4/5 and 3/5, but it would be 3 of those 1/5 down the number line.
Cool. Or 2 back from the 100%. Nice. And so now we could also have 3/5 hanging about where we would put 60%, and we could also clothespin to that 60%. Either one could have come up first. Cool. Nice. Nice. I like it. Okay, so interesting. It feels like we started with a problem today, 4/5 and 3/5, which is bigger, where you talked about, how do I say this? Could you kind of generalize when you said like 4/5 and 3/5? What was the same in that problem?
The size of the piece was the same, and in one of them I just had more of them. So like I had fifths in both of those cases, but I had 4 of them versus 3 of them, so I could compare.
Cool. And I love how you just said that, because what you didn't say first was, well, they had the same denominator. So I could just compare the numerators. That I hear that a lot when teachers are talking about comparing fractions, and I would encourage everyone to talk about that same denominator, so 4/5 and 3/5, as what's actually happening. Oh, I've got the same kind of pieces. I've got fifths, like Kim just said. And so then I can say, well, if I have the same kind of pieces, which one's more? 4/5 therefore is greater than 3/5. So if I said to you, Kim, what's bigger? Now, this is going to be tricky over just audio, but let's try it. So I've got written A seeths. So like A fraction bar C. So I've got A 1/6. Does that make sense? Or B seeths. So if you guys can picture, let me just say it for listeners. I've got A divided by C or B divided by C. A fraction bar C or B fraction bar C. A seeths or B seeths.
Such a weird thing
How
to
are you
say.
reasoning about that? Which
okay,
one's bigger?
so in both of those cases, I have seeths.
I know, it's terrible.
So the one that's going to be bigger is if A is more or if B is more. So in other words, if A is a bigger number than B, then A seeths is going to be bigger than B seeths.
Cool. So once you have the same kind of pieces, you can compare how many of them you have.
Right.
Nice. Cool. Okay. Then the second bit of numbers that we compared, 3/4 or 3/5. Could you kind of generalize the way you did that?
Well, that one was based off of the understanding of the 1/4 and the 1/5. So let me mention that one first. So 1/4 and 1/5. In that case, I had the same amount of something, the fruit strip, the candy bar, the whatever, and I'm sharing it with less people or sharing it with more people. So the smaller amount of people I'm sharing it with, the more I get.
So when you originally said you had the same amount, I think you meant you had the same whole, the same unit, the same, like, and you did say fruit strip, right? You had the same whole fruit strip or candy bar, and then say that, and then say the rest of it. You have the whole. I kind of got stuck there. So you have the whole.
I have the whole thing.
The whole is the fruit
the
strip,
whole thing, and I'm either sharing it with a smaller group or a bigger group. So the more people I share it with, the less I get.
The smaller your share is. Yeah. So that's why 1/5 was smaller than 1/4.
Sharing with more people, so I get a smaller portion.
Cool. So the ones were the same, right? It's my one share out of sharing it with
The
sharing
whole
on
is
4
the same.
people, or
Yep.
my one share sharing with
Yep.
5 people. And so then I asked you 3/4 or
Yep.
3/5.
And in that case, I considered the fact that we had 3 of the pieces, but I considered the size of those pieces. Was I sharing the whole with 4 people and I get 3 of them? Or was I sharing the whole with 5 people and I get 3 of them?
That's where the
Mhm.
3/4,
Mhm.
3/1/4, or 3/1/5
So it
come
goes
in.
back to understanding that unit
Cool.
fraction.
So yeah, nice. So if I just got very general again and said, all right, this time, Kim, you've got a
Okay.
beeths.
Okay.
So like a fraction
Uh-huh.
bar b, a beeths, or a seeths, a fraction bar c. Which one's bigger? How would you generalize that? I've got a beeths or a seeths.
Right. So we have the same amount, the same number of pieces. So I could compare, is beeths a bigger portion or is or seeths a bigger portion?
And when you do that, how do you know if beeths or seeths are a bigger slice of the fruit roll up?
Well, I don't think I would know if beeths or seeths are bigger.
Does it have anything to do with B or C?
Well, yeah. So if B is a larger number, like a 4, and C's smaller, so it's like a 3, then I'm sharing it more people. So I have to think about, am I sharing with more in B or less in B? It's kind of weird to say. Sorry.
So let's say B is really big. It's like 50.
Okay.
So you've got a 50ths compared to a fourths. Then the what does the bigger number tell you?
The bigger number means I'm
The
sharing it with
50.
more people, so I get less. So the
So
larger the
you get
number
less.
in the denominator, the more that I'm sharing it with, the smaller I get.
The smaller the pieces. So if you're comparing a beeths or a seeths, then you can compare B and C. You compare the denominator. And like you just said, the bigger that denominator is, the more people you're sharing it with. Therefore, the smaller the fraction would be. Woo! All right, y'all. We want students to be thinking about the meaning of numerators and denominators and sharing, and using this equipartitioning idea of how we can sort of split things into these equal places. And that is super important. One thing you need to know is your perspective. You might have thought that fractions are all about memorizing to compare, that there's some sort of sequence of steps that you have to follow in order to compare. Maybe a butterfly. But you can actually think and reason through them. Also, you might have had a different perspective where you might have been reasoning about fractions, but you're not quite sure why others just didn't naturally do it. And so I guess they need the rules to reason, and which we would say, no, 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 no. No, they just need to know it's a thing. Like, as a student, if you would have said, oh, you can actually reason through these, you don't have to use this rule. I just bought into it. When you said use this rule, I was like, oh, okay, that's what I'm supposed to do. So I did it. If you say, no, what you're supposed to do is think, then I'll think and obviously help me build the relationships to be able to do that. So y'all, it's about perspective, and we can once we acknowledge what perspective we had as students, then we have the option to shift that perspective and teach more and more real math.
Yeah, and I'll just pop in that we can give them the quiz one more time. They can find out about the perspectives by taking the quiz at bit.ly/XYZ quiz.
Yeah, absolutely. Take our quiz, and we can keep gathering data on those perspectives. And you also then will get a printout, a report of how your perspective might be impacting the way you teach today. And that can help you then decide how you want to keep teaching. Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com and keep listening to the podcast. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisforgettable.com/challenge. Join us to make math more and more figure outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.